We're looking at the basic homological system, how to, you know, just briefly explain how um, electric power, the parts that it takes for it to get to our various homes, right from right from the power grid, even to our television set, our microwave oven, and the rest of them. There is a part it takes, and the electrical power we use is, basically generated by a power plant. Power is sent to a power grid, starting, with the substation, where a step-up transformer increases the power to an extremely high voltage, mostly in the range of 3,000 volts to 500,000 volts, and high voltage transmission lines are used to serve the power to cities and towns that may be hundreds of miles away. And basically at these power levels, the mode of transmission is, typically very easy. But it just comes from the power generating plant, straight into those large transmission lines, and before it gets to, the different homes. But before the power can be used, it is stepped down, to the distribution grid. At that place, power is prepared for distribution. The substations where step, step up, step down transformers, can now step down and reduce the voltage to about, 7 kilovolts, depending, you know, can the power is now sent along the straight power lines to residential and commercial customers. The job of the transformer is, to now to reduce, that power, that very high voltage level, basically at around, 7,000 kilovolts, down to, 240 volts. So we can be able to use it in the home, which is needed for normal household electrical service. And there are three wires that run to every house. The bare wire, it's mostly called the ground, and the two insulated wires, each carry 120 volts. And this arrangement all majorly allows, a homeowner to use, both the 120 volts and the 240 volt appliances, depending on which one you are using and which area it is in your homes. Okay, this is a picture of the service head, and it is used to anchor the three service wires to the home. And from that point, the wires can now be directed, to your electrical meter. And the wire from the service head are now connected to an electrical meter, which is usually mounted, to the side or sometimes inside the house. And it is used to register the consumption of electricity. I'm sure most of us are familiar with how the electrical meter is. And that's what, most power technicians, when they come around to check, your power usage, that's what they look at, to look at the amount of consumption you have used by a period of time. It is used to register the consumption of electricity in kilowatts per hour. That means, kilowatts hour equals to 1,000 watts of electricity used for each hour. And the meter is not your property, though it is in your house, but it is owned by your local power company. It is protected by law. If they catch you tampering with those meters, there are severe punishments for those. I'm sure most of us don't know all this, but once you are caught tampering with the meters, even though it is in your house, you should not even tamper with it. Once you are caught, there are still penalties. to punish those that are caught tampering with the meter. So then now there is a service panel, also known as the fuse box, or you know the box breaker, or the breaker box, which of the one you are very familiar with. And it is where power is distributed into individual circuits throughout your home. And the circuit breaker is used to protect each circuit by opening it in event of a short circuit. That means it breaks the line of circuit when there's a short circuit, so it won't damage some of your home appliances. And those breaker or fuse should basically be identified so that you can tell which is connected to which. You know which one is connected to the electrical bulbs, or which one is connected to some high power consumption equipment like like electrical iron, the microwave oven. You just know how the arrangement of those electrical systems is, so you know which one is connected to which. So if there is a surge of evaporation and you want to break that line of electrical supply, you know which fuse you need to quickly deal with, to open up that connection so electrical power will not flow. So let's look at the circuit basics, how circuit flows. Circuit flows along a path called current flows rather along a path called the circuit. And each circuit that runs through the house originates at the service panel. Each circuit that runs through the house starts from the service panel. And this is just a pictorial representation of what we're talking about. And the current flows through the circuit in a continuous loop and then returns to the service panel on a neutral wire. That is the job of your neutral wire. There can be any number of receptacles like your switches or lights and other devices can be attached to that circuit. And if an appliance requires a large amount of electricity, we can now dedicate a separate circuit which will run exclusively for that appliance. And as I mentioned previously, each circuit is protected, and if there's an overload or a short, a circuit breaker or a fuse, and the panel will cut off the power to that circuit. And most times, most of these wires are identified by their color. They are mostly identified by their color. And there are three wires in a 180-volt circuit, which includes the black, or sometimes red, which is the light one, or the hot, the white or gray, or the neutral, and the bare copper or green insulated, for the ground. The ground wire is extremely important because it helps to conduct current in the event, when there is a short circuit or an overload. It also helps to reduce the chances of severe electrical shock. This is just a pictorial representation of what we're talking about, how power is distributed to the house when it comes from the base station and all our lines and rest of it. So the service panel, which is the circuit breaker or the power breaker, depending on which one you're familiar with, is definitely found in every home and is usually located in the basement or in the garage or outside the door, depending on where you have yours. And it's essentially identified by its always, most times found in that metal casing, which is the heart of the electrical system. And the purpose is to distribute power to each circuit in the home. And there are three main service leads that enter the service panel from outside the home. Two of the wires connect with the two hot bus bar lugs. Each bus bar carries like 120 volts. For appliances such as the electrical range or large air conditioner, two bus bars are combined to get your 240 volts. The wires that both the main circuit breaker always very hot. And when you see your circuit breaker, the wires that come, those are the wires that come from the service lines that comes into your home, and they are hot. What I mean they are hot, that most times carry electrical, power, and you should be very careful. You don't touch them. You understand? You know, and it doesn't matter if the circuit breaker is on or off. That wire is always it's always live. And the third wire is connected to a log in the neutral bus bar. That neutral service lines are connected to the neutral leads of the ground circuit. And the neutral lead carries current back to the power source. That's the job of the neutral lead, that's the neutral wire. It carries current back to the power source, to help you complete that circuit. And you should know that all branch circuit, ground, and neutral wires are connected to the neutral bus bar. Before any type of work can be done, you must definitely go to the terminal service panel and make sure you shut off the power to the circuit on which you'll be working. Or just better to shut off the power to all circuits. So we'll be looking at the circuit breakers and fuses. And the circuit breakers and fuses are designed to protect the electrical system from being damaged in case there is a short or overload. Most homes have circuit breakers. Let's say most. But when you see some connection in some houses, you wonder where the circuit breaker. Some people just draw line from the service, switch panel to their homes. But a decent home should have a circuit breaker, and it is mostly like a switch, that shoots up and on, in the event of a high amount of current, which the circuit breaker cannot, hold. And the circuit breaker will trip when there are too many appliances, connected on that circuit. There are several types of circuit, but a single pole circuit breaker protects one 30-volt circuit, and the double pole breakers protect the 240-volt circuits. And inside that circuit breaker, there is most times there is always a metal strip, that from the supply of circuit heats up and bends when current passes through it. So when there is a circuit shock, when there is a short circuit, or there is an overload, that metal strip will now bend and trip the circuit breaker. And if this continues to happen, even though the cost has been diagnosed and corrected, the breaker will have to be replaced. That means it is bad. So this circuit breaker has an amperage rating. That means there is a level of current it can take before it breaks. So they mostly come with their amperage rating, which indicates the maximum load it can handle. You understand? So the circuit breaker are offered in a wide range of amperage depending on the one you want, and the amount of appliance, the load that you want it to trip off, depending on your need. So let's look at the GFC, I got the ground fault circuit interrupter, and the breakers that offer protection against short circuit, caused by water or moisture. It's the NEC, that is the National Electric Code, always requires them for outdoor wiring, such as wiring from swimming pools, from spas, from those that have hot tubs, jacuzzis, and the rest. Ground fault circuit breakers are also recommended for workshop and areas where power tools are in use. And the main advantage of using breakers is that when an overload or short circuit occurs, a breaker can be reset, but a fuse must be replaced. That's the difference between circuit breaker and fuse. Fuse have a narrow zinc strip that melts when they overload. Okay, let me just, because I'll be sending this material to be getting this material, and some of us that that like to be very inquisitive and they like to quickly try their hands on things. Let me just sound this note. That is why it is rated in red. This manual does not provide enough information for you to work on a service panel. Please never touch any part of the service panel without proper training or supervision. Please, it is a matter of life and death. Thank you. So let's look at grounding. Grounding. I'm sure most of you are familiar with that word grounding. What is grounding? So the neutral wire provides a path for current to return to the power source. A ground wire will act as a safety feature in case current tries to now flow back using a path other than the neutral wire. This condition is known as short circuit. When current tries to flow back using another path instead of that neutral wire, you know, and if somebody now touches that appliance, it can result in severe shock. You know, it can be very dangerous. If something metal becomes short circuit and you touch it, current will flow through your body instead of the neutral wire in an attempt to do what, to complete that circuit. You know, because current will always find an easy path to travel. So if you come in contact with some form of ground, whether it's a puddle of water or the kitchen sink or your tap or whatever you know that you use for storing your clothes, you know, and it is used, it has become turned into ground, my brother, it is very severe thing. That's why years of people touch food and they shoot. So if you touch a hot water and you are grounded in any way, current will flow through you, considering you are the circuit. You know, you will think that touching a ground wire cannot electrocute you, but this is not true. If you touch a ground wire and an appliance on that circuit is plugged in and turned on, you may be electrocuted because you provide the earth ground that the ground wire is searching for. This is just another reminder that you must find the right breaker, shut it off, and test the circuit before you begin to work. Remember that electrical work is quite safe if you are very cautious and you use your head. So your local electrical codes require all wiring systems to be connected directly to the earth. These are accomplished by running a ground wire from the neutral bus bar in a service panel to a grounding rod. I'm sure you all know what a grounding rod is, but most of you should know. A grounding wire, should also be connected to a metal cold water pipe, because if there's a short circuit or overload, electricity will travel along the ground wire and go into the earth where it's rendered harmless. You will be familiar with polarized plugs and receptacles. It's a picture of it. A two-slot polarized plug, and receptacle is designed to ensure that the current flows travel along the black or red wire without any black or white or gray wires. They are all embedded in this one. So in new homes, code requirements call for 3-slot receptacle. An additional ground wire is attached to all the receptacles and metal boxes, providing an additional path for current to travel in the event of a short. When a 3-prong plug is plugged into a 3-slot receptacle, appliances have added protection for short circuits. Let's see the National Electrical Code. The National Electrical Code was devised and is currently published by the National Fire Protection Association, and is designed to protect people and property from electrical hazards, and it combines the installation of electrical wiring and equipment in residential and commercial properties. So where any state or local government adopt the national electric code, it definitely automatically becomes law. Local electrical code conform to the national guidelines. Local codes govern the size and type of electrical equipment, as well as the method used for installation. So before you begin a project, you should check with the local building authority to see if a permit is necessary, you know. And the Uniform Plumbing Code and the Uniform Building Code are also important in home construction. All these codes are enforced to protect you from injury and property loss. So let's look at let's look at cables and wires. Cables and wires. So when two or more wires are enclosed inside a plastic sheathing, when two or more wires are enclosed inside a plastic sheeting, it is called a cable. When two or more wires are enclosed inside a plastic sheeting or insulator, it is called a cable. It's called a cable. The most commonly used cable today is the non-metallic cable, which is most usually referred to by the brand name Romex. Romex, you know, type NMB is used for most indoor wiring applications. In type NMB, the non-metallic, B is used for most indoor wiring applications. NM cable is marked to indicate how many wire it has, as well as the gauge, that means the diameter, because you understand, we know that the higher the size of the wire, the higher the amount of electricity that can travel through it, So, so sorry. So, as the gauge number lowers, the diameter and you know the diameter and the current carrying capacity increases. And if the wire is too small for the job, it can get dangerously hot and possibly burn and cause a fire. So before you begin a job, determine the electrical requirements of the circuit and choose the wire accordingly. A two-wire and three-wire cable is shown in the photo above. A cable, a cable marked 14.3 has three insulated 14 gauge wires plus a ground wire. A strip of paper is included to protect the individual wires. So when the cable is stripped, you'll find different colored wires inside. Each color indicates the function of the wire. Like I said initially, the hot wire is covered with black. The hot wire is covered with black, or in some instances, red. Red wire is covered with red insulation and carries current from the power source. This is where current flows from. The neutral wire, hello, can you hear me, Sayani? Hello? 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 The neutral wire is covered with either white or gray insulation, and the job is to return current to the power source at 0 voltage. And the job of a ground wire is usually bare copper or grain insulated, and it's used to do what? Carry current to the earth in case of a short circuit. In case of a short circuit. Let's talk about safety. As with any project, safety should always be our primary concern. So we should always use our common sense and always exercise caution whenever we are working, in an electrical environment, because it can, once you are not taking caution and something goes wrong, it can be very fatal. So always remember to shut off the circuit breakers and test the circuit for power before you begin working. Never turn the power back on until the job is completed. Make sure that those that are working for know that there's somebody working in the house. When somebody else comes in and thinks and looks at why is the light off, and just goes and switch on the light. Make sure that nothing comes back on until you are finished your work. Other safety precautions include all switches, receptacles, metal boxes, and light fixtures should be connected to a ground, because this allows any errant current to return to the service panel and then safely into the ground by way of grounding rod. Never ever touch any metal fixtures, faucets, or pipes while working with electricity. Electricity will find a path to ground, even if it has to go through you to get there. Use the correct wire. Wire that is too small for the job can get hot and melt, which will cause a fire. So when working on electrical projects, make sure you wear sneakers with rubber soles. Please always make sure that you are standing on a dry surface, not on a wet surface. Very important. And if you are unsure about what is correct and safe, consult the advice of a qualified technician. You know, if you are unsure about what is correct and safe, consult, the advice of a qualified technician. Let's see the residential electrical wiring training. For those that want, to put their hands on how to wire and, a room, this is just an electrical wiring trainer. And the electrical wiring trainer is used to provide an introduction to electrical wiring techniques. The knowledge and skills you gain from these activities will enable you to identify and demonstrate proper wiring of common electrical fixtures, as well as the skills to wire some of the most common electrical circuits. You also learn how to work in safety with electricity. Safety should always be your primary concern, and it will be emphasized in each of the activities. This manual includes illustrations to help guide you step by step through each procedure. Using the trainer, you will be able to demonstrate the operation of a service panel and how it is used to distribute power and protect branch circuits. And in this manual, you will perform the following activities. One, you are going to learn how to wire a sub panel. You might not be able to do the practical, but I will show you the step by step and the pictorial presentation using the residential electrical wiring training to how to wire a 30 amp 120 240 volt receptacle. How to also wire a switch controlled light fixture. How to wire a switch controlled receptacle. How to wire two receptacles arranged in sequence. How to also wire a switch controlled split receptacle. You also learn how to wire a three-way switch and light fixture. How to also wire a doorbell. How to install a coaxial cable jack, and how to install a phone jack. So, since the residential electrical wiring trainer operates mostly at the 24 volt AC, there are few dangers associated with its use. So at that level, it can ensure of no shock. However, you should always exercise the same precautions that you will follow as if you are working with standard household electricity at 120 by 240 volts. So you learn more about these precautions as you perform these activities. So for your protection, the residential wiring trainer comes equipped with a transformer. This is pre-wired into the panel and steps down the voltage from 120 VAC to 24 VAC. The switch on the transformer board to be turned off whenever the trainer is not in use. There are three front panels. Each is attached to the trainer with posts and clips. Across the top of the trainer, you will see three notches. Each notch allows you to get a firm grip on that panel for easy removal. You should place your finger behind the panel whenever there is a notch and pull it towards you. The panel will then snap on the post and come off. Replacing the panel is also easy. Line up the upper and lower clip with the matching post, then hit the panel gently on the top and bottom with the palm of your hand. If the wire protruding, make sure that they don't cause any obstruction. And then another one is the lessons, in the common modules, are designed as an overview of several aspects of residential wiring. And the purpose of this lesson is to improve your understanding of residential electrical wiring. So completion of this lessons activity does not qualify you to do the type of work in your home. Remember, a wiring can be extremely general. They are not careful and don't follow the rules. Never attempt any type of wiring project without permission by the licensed electrician. So in our next class, we'll see how to wire, solar panels and do the rest of them. So thank you, and see you in our next class.